Here are some extra examples to go along with our fundamental trig identities. So we are going to simplify our fractions and not have any fractions in the answer. Sorry, simplify our expressions and not have fractions. So secant squared of x times cotangent of x times cosine of x. Well, secant squared can be rewritten as 1 over cosine squared. Cotangent can be rewritten as cosine over sine. And a cosine here. And now I see, oh, cosine squared, those all cancel, leaving me just 1 over sine squared, or sorry, just 1 over sine of x, which is cosecant of x, and now it's simplified. All right, sine cubed of x plus sine of x times cosine squared of x. Well, I see a GCF I could factor out. I'm going to take a sine of x out of everything. That leaves me sine squared of x plus cosine squared of x. And sine squared plus cosine squared is 1. So I just have sine of x times 1, which is just the sine of x. All that craziness simplified to just one simple thing. All right, now we're using odd and even and the cofunction. So the cotangent of negative x, if I look at my formulas, I have negative cotangent of x. Cotangent of pi over 2 minus x is tangent of x. Cotangent and tangent are reciprocals of each other. I can write cotangent as 1 over tangent times tangent. Oh look, they cancel each other, leaving me just negative 1. I also could have turned it into sines and cosines if I felt like that. All right, this one looking all sorts of crazy, but I see conjugates up here. I'm going to multiply them together. That makes secant squared of x minus 1 over sine squared of x. Secant squared minus 1 is a version of a Pythagorean identity. It gives me tangent squared of x. And I happen to know that tangent squared would be sine squared over cosine squared. I'm going to write my divided by sine squared next to it now because that helps me. Because when I divide by something, I can multiply by the reciprocal. And now my sine squareds cancel, giving me 1 over cosine squared of x, which is secant squared of x. You might be wondering, is there a different way I could have done that? Absolutely. There are many, many different correct ways to do these problems. I'm just showing you one. All right, for this next one, all sorts of options. I would say, I see 1 minus sine of x. I'm going to multiply this fraction by 1 plus sine of x. So I have cosine of x times 1 plus sine of x over 1 minus sine squared of x minus tangent of x. I know 1 minus sine squared of x is cosine squared of x. And I know that I can cancel one of these cosines out. So I got 1 plus the sine of x over the cosine of x minus tangent of x. And now I can split that fraction into 2 pieces. So I can make it 1 over cosine of x plus sine of x over cosine of x minus tangent of x. Well, sine of x over cosine of x is tangent of x. Tangent minus tangent makes 0. 1 over cosine is the secant of x. Done. There's my answer. All right, tangent squared of theta minus 1 over tangent of theta sine of theta plus sine of theta. All right, my first instinct is the denominator. Both terms have a sine of theta. So I'm going to go there first. That leaves me tangent of theta plus 1. And what I see in the numerator tells me that I could actually cancel some things if I factor my numerator. My numerator will factor into tangent of theta plus 1 times tangent of theta minus 1. And my tangent of theta plus 1's cancel, leaving me tangent of theta minus 1 over sine of theta. And now I split this into two fractions. Tangent of theta over sine of theta minus 1 over sine of theta. Tangent of theta over sine of theta. Now I'm pretty sure I've simplified that before, but remember it is sine of theta over cosine of theta divided by sine of theta. And 1 over sine of theta, I'm just going to change that to cosecant right away. Now when I divide by sine of theta, remember that I'm multiplying by, there we go, multiplying by 1 over sine of theta. Keep that cosecant down there. The sines cancel, leaving me 1 over the cosine of theta minus cosecant of theta. 1 over cosine is secant of theta minus cosecant of theta. There's my simplified version. All right, your assignment for this whole section was out of the textbook.